Hello all, welcome to the Linux Rootkits for Red Blue Teams course on Pentester Academy. Now in this video, we'll continue to look at kernel module basics and understand a little bit about the printk function and console log levels. So if you've done a bit of C programming, we've all used printf, right, to print formatted text onto the screen. Now in the kernel, printf gets replaced by something called printk, which is very similar in behavior, but it ensures that it can actually function within the kernel. So let's actually jump right in and look at some of the code. So I'm going to go inside our Linux directory. I'm going to open up include Linux printk.h. Okay, so the very simple invocation of printk is exactly how we use printf in user space. Let me actually show you some sample code. So I'm going to go inside and again, you should be able to find 003 hello world printk from the GitHub repo. So I'm going to open up this file. Now, in all videos following from this one, I'm not going to type out every single line. It just takes an astronomical amount of time. So I'm going to go ahead and just explain with the help of written code, right? That will be faster and serve the same purpose. So what we are trying to look at in this video is how to use printk, which is similar to printf. Now, if you notice, we have our very first printk here inside the init function. And what we've done is we have gone ahead and prepended some kind of an identifier which says kern_info and followed by basically the string which says hello kernel info, right? This is the first line. Now let's go back to our code, the kernel source code. And we actually go ahead and take you back to the slides. Okay, now when we are looking at printk, the whole idea within the kernel is that anytime you're trying to print out something, of course, there is no real screen or something where the kernel can put that to, right? So the kernel is going to send it to maybe a connected console or to a syslog file so that the administrator can look at it later. And this is really where in the kernel, any single time we use printk, it is important to mention the log level, which is this just an informational printk, or is this a printk which should be taken with a lot of emergency? Is this an alert, right? So based on that, within the kernel, we have these defined 8 levels, starting from kern_debug, which is debug level messages. This has a log level of 7, followed by info, which is informational, then notice, warning, error, critical, alert, and emergency. Okay. And the smaller the value, the more important the message, right? Kern emergency is pretty much, as you can see, typically used when the system itself becomes unusable. So these are the different log levels, and it's important that we tag every printk with one of these log levels. So how do we go ahead and do that? Well, as I've shown you here in the code, we basically prepend the log level, which could be kern_info or whatever, followed by the string which actually defines the real message. So in this case, we are printing an informational message, printk kern_info. Now, what basically the Linux core group of kernel developers have done is, rather than have to go ahead and mention kern info every single time we want to put out an informational message, they've created a little shortcut, a very simple macro called pr_info, which really expands to this. So if you look at the definition of pr_info, what you'd see that it's been defined as a macro which expands to printk kern_info, followed by the format string and a variable list of arguments, right? And this is similar to printf, which we've used in the user space. Now, similarly, for kern alert, we have pr alert. For kern emergency, we have pr_emerge. And every single log level has one of these shortcuts. Now, why this is really useful is A, it takes the ambiguity out. B, it makes it much more easy when you're reading the code to just quickly look at PR info and know this is just an informational message, right? Now, arguably, you can figure out the same thing by seeing kern info or kern alert. But, for some odd reason, definitely it's much more difficult to read all bolds and figure that out in the code, rather than something where the name of the function itself makes it very evident. Great. So now let's do the following. I'm going to go ahead and first of all clear the kernel log. So to do that, if you do a man d message, we'll actually see that in order to go ahead and clear the log, we can do the -c option. So sudo dmessage -c. Now if you type in dmessage, we see there are no messages in here. Fantastic. Now let me go ahead and compile this program just like we've done in the previous videos. And now let me actually do a sudo insmod hello world printk.ko. And if you notice, nothing really happened. There were no messages put out on the terminal, and I'll explain why in just a bit. If you look at dmessage though, we should be able to see all the messages for PR info, for kern alert, which even gets colored fancy, and then even for kern emergency, right? All of these actually get printed as part of the kernel logs, which is great. So we have accomplished it. And at the very same time, we now know that each of these logs, if you have a good quality log reader, can actually be treated differently. So of course, the next question arises, why was nothing really printed on the screen? Now this is really where one has to understand the difference between a terminal like this versus a console. A console traditionally would actually be a hardware terminal. It could be a UART port or whatnot. Now if you wanted to access the console, let me actually first remove this module. If you wanted to access the console, you could do a Control Alt F1 F2 and it'll kind of juggle you between the consoles. So if I do a Control Alt F2, I'd actually see that now I arrive on one of the consoles. Now, unfortunately, in my case, it just shows this in a really ridiculous small screen size. So you'll have to bear with me. I'm going to log in as Vivek, password is Vivek. And let me actually go inside the class directory. And now I'm going to do a sudo insmod hello world printk.o, right? Now once I do this, notice something interesting. What will happen? I can actually see now the log messages getting thrown on the console. Do you see that? Now if you look at it closely, you'll actually find that we only see kern alert as well as the emergency message, which is kern emergency. We do not see the kern info anywhere, right? So I'll come to why that is in just a bit. But the key thing to notice, if you go ahead and basically are running and connecting to the system over an actual console like this one, then you will be able to see the log messages on your screen depending on the console log level, which I'll talk about in just a bit. But if you go ahead and only use the terminal, or rather the GUI based terminal, you will not be able to see it on your screen, right? I'm going to again remove this module. So once this part is clear, the next part is, well, why wasn't kern info messages shown on the screen, right? So when we looked at this, we found that we've seen alert, we've seen emergency, but not info. Why is this? Let's demystify this part. Okay. Now on a Linux system, as you can imagine, we have these 8 log levels, and if every single log was actually put out, including debug messages, informational messages, and whatnot, the actual console would become totally unusable. And this is really where it was important that we make the console log level kind of configurable so that we can tell the operating system, what logs are we interested in to be shown on the console. Of course, everything gets, eventually stored into the syslog or wherever we've configured it. So none of the kernel messages are lost, but the ones which will be shown on the console get dictated by the console's log level. Okay. Now there are 2 places where we are actually going ahead and configuring this. First is when we compile the kernel itself. In the .config file, what we actually have is the config console log level default. So let's actually go inside the VM. I'm going to go back to the GUI once again. And let's actually go to the kernel directory. Just going to do a make menu config. Okay, now if we go to kernel hacking, at the very top you'll actually see printk and dmessage options. Let's go in there, and if you notice, there are a bunch of options here. The second one, which says default console log level, right? If I type in an H, this basically tells us default log level to determine what will be printed on the console. Setting a default here is equivalent to passing in log level equals XX in the kernel boot args, blah blah blah. So this is the very first configurable parameter, which is what is the default console log level. And what this means is that any log having a log level higher priority than this value, which is 7, will actually be printed on the console. And typically at boot time, that's the reason why you end up seeing a lot of those messages kind of getting printed, right? So this is the console log level, the default one, and which can be reconfigured by the OS once it completely boots in, right? The second is the default message log level. So what is this? So let's say that you end up creating a printk statement, but forget to give the log level, which is you forget the whole kern underscore, the next 4 letters. Then that message assumes this default log level. So which has been configured to be 4. And if we were to actually exit, and look at kern levels.h underscore levels.h, we'll actually see is the bare minimum seems to be kern underscore, warning is 4. So which actually means anything above this will be printed, which is error and above, right? Is what will be printed. Now this is configured at compile time, and of course, as soon as the OS boots in, it can change the default log level. And at the very same time, this is something you can even change or configure. So to look at the current log levels, we can do a cat on proc sys kernel printk, and we'd find 4 numbers. The first number is actually the current console log level, and you can see that it has been kind of brought down to 4, which means anything which is of higher priority than 4, which is lesser than 4, gets printed. The second one is the default log level, when no log level is specified, right, which is really the message log level, which defaults to 4. The third number is the minimum value of the console log level, which it can take, and followed by the default value of the console log level. Again, this is basically this value in here. So if we go back to our VM and actually say cat proc sys kernel printk, can actually see those values, and we can see the default console log level is 4, and hence when we actually went ahead and inserted the module, we were not able to see the PR_info messages. Let's go back. So to change this, we are going to use the dmessage utility. So this is the utility we are going to use. And if we do a man dmessage, what we'd find is there is a -n parameter. Here it is. And this allows us to change the console log level, right? So I can actually type in sudo dmessage -n7. And once we do this, if we go back to our console, and let's now insmod the module again. And there you go. If you notice, we can clearly see kern_info is now showing up just as expected. Fantastic. So as you're clearly seeing, the log level, the console log level ends up dictating what actually gets shown on the console. Fantastic. So hopefully everything was clear in this video. Printk, the different log levels, and how you can use the shortcut macros, which is PR_XXXs. And then after that, how you can change the console log level using dmessage so that you can go ahead and show more messages with lower priority on the console. So that's all I had in mind for this video. Okay, there's one more thing. Not so fast. So printk, just like printf, has a lot of options for printing formatted text. And this is where the kernel.org guys have a documentation page located at doc documentation printk formats, where they've mentioned the different formats. What you'd find very, very interesting is the printing of the pointers themselves and physical addresses. And I'm going to take this up later and explore some of these printing when we actually look at memory addresses and stuff like that, right? So I'm not going to overcomplicate things right now. Okay, so that's all I had in mind for this video. If you're enjoying your time at Pentester Academy, please recommend us to your friends and colleagues in the InfoSec community. Thank you.